Hi guys, I just want to do one more example here. Same idea as last time. I have an equation and I'm solving for an unknown, and then I have numbers to plug in to get that final answer. So the first thing I'm going to do is rearrange my equation to solve for the unknown. Now, it's a problem that I see students running into all the time. They're not quite sure what to do when the unknown is in the denominator. And so your first step is let's get it in the numerator so we're not worried about an inverse or a fraction when we're solving for this. So I'm going to multiply both sides of my equation by r squared. So that way I get r squared multiplied by force g m1 m2, okay? And then I want to isolate r, so I'm going to divide by force. And then the last step is this is squared, and so I can get rid of that square by taking the square root of both sides. So I would have r is equal to the square root of g m1 m2 over f, okay? Now let's use a unit analysis to make sure that we rearrange this equation correctly. R in this situation stands for radius. So we're wanting to end with a final answer of a distance, which would be meters. Okay, so we're anticipating meters. Now, something I'm noticing when I look at this, newtons are good, kilograms, I have base units here, kilograms is good, but this is grams. And so we need to convert that to kilograms. So I'm going to take my 24 grams down below so it cancels, kilograms up above. 1 kilogram contains 1,000 grams, and so I get 0.024 kilograms. I started with 2 sig figs and I ended with 2 sig figs. So that's the value that I'll use. Okay, G is a Newton meter squared per kilogram squared. Let's just focus on the top of the fraction first. Let's just focus there. So I'm going to have a Newton meter squared per kilogram squared. And then I'm going to be multiplying that by mass, which is kilograms, and then mass, which is kilograms. That cancels with one of those, and then the second one there. So on the top of my fraction, inside the radical, I have a Newton meter squared. Now I can lay out what that Newton is, but I want to see if that's necessary before I do that, because it was convenient not to have that all broken out here. And so now I'm going to say I'm going to take a Newton meter squared, because that's on the top, and I'm going to divide it by force, which is Newton. So I'm going to take a Newton meter squared, and I'm dividing that by newtons. Dividing by a fraction is the same as multiplying by the reciprocal, and so I'm left with meters squared. But this was all inside the radical, right? Every single bit of this. And so that cancels the squared, essentially. So we end with meters, and that's what we were hoping to get. So we rearrange this correctly. Last step would be plugging in the numbers. So inside my square root, I have G, which is 6.67 times 10 to the negative 11, multiplied by M1, which is a 0.024 kilograms, multiplied by M2, 5.972, 10 to the 24th. And that's going to be divided by the force, which is 0.235 newtons. Most common mistake, I think, on this one is just calculator error. So if I have a fraction like this, I need to tell my calculator keep all of this on the top of the fraction. So I have my radical, and again, you can chunk these calculations, but I wanted to show you how you could potentially plug this in all at once. So inside the square root, we want the entire fraction. Now, on the top of the fraction, we have a number in scientific notation multiplied by 0.024 multiplied by another number in scientific notation. Okay, that's the top of the fraction. Now I'm going to divide by what's on the bottom and then close the radical. And so my calculator gives me pretty print, so I can go and see that I have set it up correctly. Yep. Okay, so I have a final answer without sig figs. Actually, I want to do an exact. I have a final answer of 6.37815 times by 10 to the 6th. I said this was meters. And now I'm going to look at sig figs. So I'll come back to my list. 3 sig figs, 2 sig figs, 1, 2, 3, 4 sig figs, 3 sig figs. That was my least amount of sig figs. So that'll be my 2 sig figs. I round up. And then I final answer in meters. Okay. So rearrange your equation to solve for your unknown. Use a unit analysis to determine if you rearranged it correctly. Make sure all your values are in our base meters, seconds, kilograms, and then plug in your numbers. Correct number of sig figs. All right, guys, study hard. You'll do great on the test tomorrow.